Hello everyone, I am hibikiaoyama from Furukawa Labo, Yamagata University. I will take about shape memory gear-based movement mechanisms on sand. First, I will explain the objective. In this study, we propose a moving system using a shape memory gear. Shape memory gears are gears with temperature-dependent elastics that became hard at room temperature and soft at high temperatures. This moving system moves by vibration. In addition, vibration state can be controlled by the shape memory gears absorbing the vibration. The image is of a soft gear-like block that absorbs the vibration of furniture such as word blows during an earthquake. It will also have a collection mechanism for the purpose of extracting resources such as sand, so that it can be collected efficiently. This soft robot was made based on a creature called a sandallar. The following is an overview of the soft robot to be fabricated. The figure on the left is a cross-sectional view of the soft robot to be fabricated. The PLA part has a mechanism for sand collection. 4 types of mechanisms are fabricated in PLA. The SMG part is made of a material that is used to control vibration through temperature changes. The flexible resin has needle-like cilia to show fluid behavior against the sand. When the SMG is cold, the vibration of the vibration motor is transmitted to the cilia, which moves, and when the SMG is hot, the SMG becomes soft, which absorbs the vibration and stops moving. We will explain 2 experimental methods for measuring change in vibration and motion due to temperature changes. The first is to measure the change in the way the vibration is transmitted, depending on the hardness of the SMG. The first is to measure the change in vibration transmission depending on the hardness of the SMG. When the SMG is soft, the amplitude is small because the vibration is not transmitted, and when it is hard, the amplitude is large because the vibration is transmitted. The second is to calculate the distance and angle of movement and rotation by running the robot at 24.4 degrees Celsius in cold water and 68 to 2 degrees Celsius in hot water. This is the result of measuring the vibration change due to temperature changes. 4 types of measurement were taken: when the SMG was soft, when it was hard, and for compression SMG and piezoelectric film only, and vibration motor and piezoelectric film only. As expected, when the SMG was soft, the amplitude was small, and when the SMG was hard, the amplitude was large. These results show that the vibration transmitted change depending on hardness of the SMG. This is the result of measuring the motion change due to temperature changes. The distance moved and the angle rotated by time were measured for cold water and hot water respectively. From the image analysis, it was found that the movement by cold water was 63 degrees rotation in about 5 seconds and 25 mm movement in a straight line. On the other hand, there is no change in the rotation or movement of hot water even after 20 seconds, indicated a rotation of 0 degree and a movement of 0 millimeter. These results show that it is impossible to switch the motion mode depending on the temperature changes. Next, we will explain the experimental method. In order to measure the sand collection capacity, we prepared 4 types of shapes as shown in the figure on the right. The sand collection mechanism is made of polylactic acid resin, and a vibration motor is attached to measure the weight of sand in 10-second increments from 10 seconds to 10 seconds, and a graph like the one on the right is created for completion. We expected that the spiral would be the most deterrable because it rotates while entering sand. This is the result of an experimental that shows the measurement of sand recovery capacity. Spiral collected the most with a weight of 1.59 gram. In 60 seconds, it was confirmed that spiral, concentric, cycle, and radial were collected in that order. Spiral was able to collect more sand by rolling it into the center without ejecting it. As you can see in the video, the reason why radial collected less sand than the cycle is because it was collected by the steps but it was also ejected. These results show that spiral is the best recovery mechanism. Finally, summary is shown in the slide. Thank you for listening.